Okay, I'm going to start talking about application problems with quadratic equations. And frequently with a question like this, you're going to be asked what is either the maximum or the minimum value something is for an equation, for some sort of function. And what you're usually going to be given is, if you're asked to find, say, a maximum, it's usually like I'm throwing a ball in the air. So I've got a height, I've got a time, and you've got, the funny thing is, with something like this, you're going to have two potential answers. Both of them involve this point, the vertex. And remember, the vertex is going to have both that x value and the y value. In this case, the x value would be at what time did it hit the maximum point. If you're asked for the y value, it is what is the maximum height. So one of the important things to do is you have to ask yourself, am I looking for the x or the y from the vertex? This is a very important question whenever you are answering one of these questions. And I've got a couple examples, and I've actually asked both, so you could then figure out which is the more appropriate way to go. All right, let's begin, and I'm actually beginning with a ball thrown vertically upward. After t seconds, the height in feet is given by the function h of t is equal to 56t minus 16t squared. Now, this first one is, after how long will it reach its maximum height? This is going to be that x value. Or in this case, it's that, I guess it's actually the t. So maybe I shouldn't say x, I should say that t value. What is the maximum height? Well, that is the y. But let's go ahead and solve this. So if I were to do this, I'd say, well, all I need to do here is find the vertex. And finding the vertex, remember that t value is going to be that negative b over 2a. Well, I've got my h of t is, my height is, I'm going to rewrite this in order here. So negative 16t squared plus that 56t. Now I look at that and I say, oh, that's going to be t is equal to minus 56 over 2 times my negative 16. And I could simplify this. This would turn out to be, let's see, 8 goes into both of those, like 7 times 2. So this would be, t is 7 over 4. That doesn't really work for a time, so I would actually just say that my time is 1.75 seconds. So after 1.75 seconds, this is at its maximum height. So if I were asked this first question, this is my answer. If I'm asked, what is the maximum height? Now, we don't always have to, if all we're asked for is time, we could stop right here. If we're asked for what is the maximum height, then I would go ahead and plug this value in. I'd say, okay, that maximum height is, h of that 1.75 is equal to negative 16 times my 1.75 squared, and then plus 56 times my 1.75. I'll have that height is going to be, what would that be? Negative 49 plus 98. Oh, so this looks like I would have a height of 49. So I would say that the height is 49 feet. That would be my maximum height. So depending on which question you are being asked, you might, if I'm asked for just the time, I only have to do this first part. If I'm asked for what the height is, I have to first do this and then continue on to finish this out. Let's do another one. Here I've got medical equipment industry manufacturers, X-ray machines. The unit cost depends on the number of machines made. If X machines are made, then the unit cost function, so the cost per unit, is this 0.9x squared minus 360x plus 40,834. And I've got two different questions here. How many units should be produced to minimize the cost? That would be, literally, that would be the X. What is the minimum unit cost? Well, that is, we're looking for the C or the Y. So the first thing that we have to do is we have to ask ourselves, how many units would minimize this? What is the X value of this particular equation? So let's figure out how many units would minimize this cost. This is nicely already in order. So I'm going to say my X value here is this negative b over 2a. So here my X is going to be negative minus 360 over 2 times our 0.9. That's 360 divided by 1.8. And that looks to me like we'll have 200. So if I wanted to know what my minimum, or how many units I should do to minimize the cost, I would say 200 units minimizes the cost. Our production cost. So there is that piece. Well, we don't know what that minimum cost would be, but all we have to do is plug it in. So here I'm just figuring out what that cost function is at 200 for 200 units. So here I will just plug this in, 0.9 times our 200 squared minus 360 times 200. Oops, and then plus our 40,834. That's going to be some big numbers. But I could plug this into a calculator and we would discover that this would be 4,834. So then I could say that my minimum unit cost is $4,834. So when you're looking at this, make sure you're only going to be asked one or the other of these, not both, or not typically both. So when you're going through this, you're going to have to do a careful reading to figure out which question you're being asked. And then if you're just asked for the X value, you can stop early. If you're asked for like the Y value, you're going to have to turn around and plug in your answer into your original equation. Alrighty, that's all I've got for now. I will see you in the next video.